Okay, today we're going to be looking at distance and midpoints. We'll be looking at them both on the number line, and then we'll also be looking at them in the coordinate plane. So first of all, let's look at our midpoint formulas. When we are on a number line, we find the midpoint of a certain segment by finding the average of the two coordinates. So over here you can see in the diagram, we have this segment AB, which is this length here. If we want to find that midpoint point M, we need to add together the number that is associated with A and the number that is associated with B, and then divide by 2. So we find the average by taking the sum and dividing by 2. When we are in a coordinate plane, it works just a little bit differently. In a coordinate plane, every point is assigned an x value and a y value. So if we were finding the midpoint in a coordinate plane, we would have to take the average of the x's of the 2 points and then also the average of the y's of the 2 points, because we want our answer to be in the form xy. So we need 2 answers, an x coordinate and a y coordinate. So let's go ahead and look at an example of each of those. So here I have a segment AB. I have that point A is at the coordinate -4, and point B, be really careful here, it's between 8 and 10, so it is at coordinate 9. Be very careful with that. So if I want to find the midpoint of AB, I just simply take the A coordinate, which is -4, add it to the y coordinate, and divide by 2. So that becomes -4 plus 9 over 2, which is 5 over 2. Now you can leave your answer like that, or if you want to write it as 2.5, that is fine as well. So if I go up here and I make a point at 2.5, which is about right there, that is the midpoint of my segment AB. Okay, moving on to the coordinate plane and midpoint in the coordinate plane. So for this, again, it's going to work a little differently. So we have that point E is at 7.5, point F is at 2, -4. And here we want to find the midpoint of EF. So in order to do that, I'm just going to label our coordinates x1, y1, and x2, y2. So we need to add together our x values, which would be 7, plus our x2, which is 2, over 2, comma, and then do the same with our y values, 5 plus a -4 over 2. So if I add those together, the first coordinate becomes 9 over 2, the second becomes 1 over 2. And if you want to rewrite those as decimals, you may. That would be 4.5, comma, 0.5. We do not combine those. Again, we need an x and a y for our midpoint. So we should never end up with just one number. So if we were going to graph that, that would be over 4.5 and then up 0.5. So the midpoint on that coordinate plane would be about right there. Okay, so we're going to take this and we're going to do a little bit more with it. We are given the midpoint of a segment is at -2, 1. So you can see that we already have that graphed over here. And then we know that one of its endpoints, endpoint C, is at -5, 7 up here. So what we want to determine is the coordinates of the other endpoint of this segment. And so what we're going to do for that is plug it into midpoint formula. So we know that if we add our 2 x's from our endpoints together and divide by 2, we get the x coordinate. If we add our 2 y's together and divide by 2, we get our y coordinate. Okay? And that gives us the midpoint. And our midpoint in this case is at C, which is -5, 7. So now I'm going to call point M, since that's the only one we know, our x1 and our y1. And we're just going to substitute that into the equation. So instead of writing x1 now, I'm going to write negative 2 plus x2 over 2. And instead of writing y1, I'm now going to write 1 plus y1, or y2, over 2. And again, that equals our midpoint, which is negative 5, 7. Okay, so now what I can do to be able to find our x2 and our y2 is I can set each piece equal to the coordinate in the midpoint. So I have negative 2 plus x2 over 2 equals the x of my midpoint, which is negative 5. And then I also have that 1 plus y2 over 2 equals my y, which is 7. So now these are just algebra problems, so I can go through and solve these. So if I multiply each side by a 2 here, these cancel and I get negative 2 plus x2 equals negative 10. Then I can add 2 onto each side. And I'm going to end up with, and I'll write that over here, x2 equals negative 10 plus 2, which is negative 8. So that is the x-coordinate of my other midpoint, or another endpoint. So now let's find our y-coordinate. So here, if I multiply each side by 2, again, those cancel, and I get 1 plus y2 equals 14. So y2 here equals 13. So the coordinates of my other endpoint, endpoint D, will be negative 8, 13. Okay, I know that one was a little more difficult, so if you have questions on it, we'll go over those tomorrow. Moving on, let's look at distance. All right, distance on a number line is really simple. So if we want to find the distance on a number line, let's just say we want to find the distance of AE. We'll do that one first. We want to find the length of that. It's just going to be the absolute values of the coordinates that are associated with. So it's the absolute value of A minus E. So for instance here, we know that A is at negative 7 and E is at positive 2. So it's the absolute value of negative 7 minus 2. So the absolute value of negative 9, which we know is positive 9. We can never ever have a negative distance. Let's look at one more. Let's do FD. Okay, we're going to go the other direction. So we have that F here is at 5. So that's 5 minus D, which is a negative 2. Okay, so a negative minus a negative becomes positive. So this becomes the absolute value of 7, which is just 7. So the length of FD is 7. Another thing you can do with these is we can count. So if we go from F to D, that's 1, 2, 3, 4, 5, 6, 7. That's another way we could do it. Let's go ahead and look at distance in the coordinate plane now, and then we're going to look at a few more things and we'll be done. So with distance in a coordinate plane, we have a formula to use there. If we have two coordinates and we want to find the distance in between those two coordinates, we can use what's called the distance formula, which tells us that distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's just go ahead and look at that within a problem and see how that works out. So we want to find the distance here of SR. Okay, so if we want to find the distance of SR, we're going to use distance formula to do that for us. So again, I'm just going to rewrite distance formula here. Okay, and I'm also going to go ahead and label my points x1, y1 and x2, y2. Some of you will not have to do this, but some of you may want to, just so you can be extra careful. So now if we're plugging that into distance formula, I have that x2 is 3 minus x1, which is negative 2, so that becomes plus 2 squared, plus y2, which is negative 1, minus y1, which is 14 squared. So this becomes the square root of 3 plus 2 is 5 squared, plus negative 1 minus 14, which is negative 15 squared. So 5 squared is 25. Negative 15 squared is a positive 225. Okay, always remember that a negative squared is positive. So this becomes the square root of 250, which simplifies to 5 root 10, or I'm completely okay with a decimal for these. That is approximately 15.81. So the distance between points S and R is approximately 15.81 units. Okay? All right, last one, and we are done with this. We're going to look at this one, finding distance. And now this is an application type problem. So I'm going to guide you through this, and we are going to do some of these tomorrow, because I want you to have good practice with that. So here, it says we have a zipline course, and we are harnessed to a cable that travels through the tree tops. We start at A and zip to each one of the other platforms. How far do you travel from platform B to platform C? So from B to C is this length here. Okay, that length right there, that's what we want to know. So we need to know the coordinates of each one of these. So B is at coordinate negative 30, negative 20, and I'm just using the coordinate plane to tell me what points they are at. And then we also have point C, which is at negative 15, positive 10. So once we find the coordinates they're at, this is just a distance problem. So we don't have to get scared by these word problems. So now we can go ahead and find the distance between these 2 points. So distance here is the square root of, and again, I'm going to label x1, y1 and x2, y2 just to help give us a guide. So that will be negative 15 minus a negative 30, so that's plus 30 squared, plus our y coordinates, which are 10 minus a negative 20, so plus 20 squared. Okay, so this one becomes then, I'm running out of room, the square root of 15 plus 30 is 15 squared, plus 10 plus 20, which is 30 squared. So this becomes the square root of 225 plus 900, which is the square root of 1125, which is approximately 32.54. So the distance between platform B and platform C will be 32.54 meters. Okay, so that is an application type problem, and we will look at more of those tomorrow in class. So last thing I want you to do is to attempt these problems. Try it. Okay, try those 3. Pause the video, work them out, unpause it, and I'll have the answers up for you. Okay, so here are the answers to those 3 problems. I have put each one in a black rectangle for you to look at. If you have issue on any of those, please write down your questions. Let me see your work tomorrow, and we'll go over those. We'll get those straightened out. See you then.